Okay. Happy Wednesday, everyone. Sorry for the misfire last week. The GoToWebinar platform seems to be working again today, so keep our fingers crossed. But we're going to get going here on this International Day of Light. Yes, during this webinar, Green Builder Media Editor-in-Chief Matt Power is here to shed some light on a few cutting-edge, cost-effective products that will improve the energy performance of your projects while saving you money, time, and hassle. Now, for those of you who don't know, Matt is Green Builder Media's editor-in-chief and a veteran and award-winning reporter. He's covered virtually every aspect of design and construction. His articles often tackle tough environmental challenges in a way that makes them relevant to both professionals and end users. An expert on both building science and green building, he has a long history of asking hard questions and adding depth and context as he unfolds complex issues. Now, before we get going, I need to take a moment to tell you about PowerShift by NV Energy. You can never save too much energy or money. That's why NV Energy has introduced PowerShift to help its residential and business customers conserve even more energy and save money on their power bills. PowerShift by NV Energy is also about providing you with excellent customer service. It's your one-stop shop to find all the energy-efficient products and services to help you boost your bottom line, along with convenient ways to manage your account. PowerShift Energy Advisors are dedicated to working side by side with business customers to discuss their needs and to find energy efficiency solutions that save money. Plus, their Business Solutions Center is the place to go to discuss your bill payments and account-related questions. For more information, please visit nvenergy.com/PowerShift. Now, I mentioned earlier that GoToWebinar had a technical snafu last week. Well, Green Builder Media is going to try and make it up to you. Everyone who is attending this webinar live will be entered to win a Sensi Smart Thermostat. So the winner will receive an email from Mary at Green Builder Media. So make sure you're looking out for that. Now, during the course of today's presentation, you can submit questions for our guest. Simply use the questions box, probably on the right side of your screen. I'll review those questions and pose them to Matt during the Q&A time that we've set aside after his presentation. All right, Matt, if you're ready, so are we.
Okay, thank you, Mike. Hello, everybody, and thanks for bearing with us. We had a little glitch last week, and I'm glad to say we're up and running now, and let's keep our fingers crossed that this goes well and the high tech serves. So today I wanted to talk about some high tech stuff, but also some sort of low tech approaches to energy and water conservation. And I usually start with sort of a big picture view when I do one of these presentations and whittle down to the really specific stuff. So let's jump in. The first thing I wanted to point out is the piece of the pie that we are going for. You see that green slice on the top of this pie chart? That's the portion of energy, and usually water use is sort of rolled in under that because it requires energy to get water, as we all know. So are we going to save the world by affecting our 22%? Well, maybe if we could get it down low enough. I mean, we're not trying to do everything, but in this webinar, what we're going to focus on is that slice of pie. Now, we're going to drill down to the next level, and this is the typical energy use for a single-family home in the United States. And as you can see, the big blue slice is the obvious winner or loser, shall we say. That's heating, and right below it is cooling. So you could really combine those two slices. That is where almost half of our energy use in a home, and this would also apply to an apartment as well, or almost any type of dwelling unit. So we really want to start with the big stuff. And this is a mistake I think that a lot of people make when they start looking at energy efficiency, both professionals and homeowners, is they focus on some of the small stuff and they don't look at the big picture and start with the big stuff and work their way up from there. So we are going to take this pie chart and we're going to go through, starting with the biggest bang for your buck, and try to knock down some of the energy use in a typical home. And along that same line, this is the Green Building Pyramid, which I developed a few years ago to try to help explain to people sort of the priorities of green building. Now, at the bottom of the pyramid is the most important stuff. It's both the low-hanging fruit, but it's also the stuff that the decisions that you make if you're building a new home, for example, early on in the building process. You'll see that siding, for example, which way does the home face? And of course, location, because location impacts your transportation footprint. That's another big picture issue. The education part is what we're doing today. If you don't know what you're doing when you're building or retrofitting, that can end up costing you more in energy than anything else. And of course, house size, way over there on the right, you'll hear the argument a lot today that because houses are so much more efficient, that we can build ever larger houses and they will still outperform an older house of a much smaller size. Now, there's some truth to that. You can build a house 3 or 4 times the size of an old house and you will use less energy. However, there is an embodied footprint of the initial construction of the house. It's usually about 11% of the overall footprint of the house. And there's a lot of maintenance issues and other things that play into the mathematics of that. So, if you can live with a smaller house size, it's always greener to go with a smaller house size. And working up the pyramid, you can see some of the fundamental sort of commodity low-tech aspects of the house that are important, like insulating the foundation and sealing openings well. It's not until you get quite a ways up the scale that we get into things like lighting, appliances, and you'll see way up at the top is where smart controls and renewable energy come in. So I wanted to show you this first, because in some cases in today's presentation, I'm not emphasizing the high-tech gear first. The high-tech gear is sort of the cherry on top, if you will, of when you have your fundamentals in place. So this is modern building science, and we know so much more than when I started almost 30 years ago covering the industry. I mean, it was really guesswork back then on how a house was built, and there's been an awful lot of good research since then that helps us figure out how to build and optimize homes and equipment. I wanted to also bring up this study, again, as we drill down. This was done, I believe, by UCLA, and we're using it this year in a project called the Align project, where we're trying to help people understand how they really use their homes. Now, this study looked at 32 different dwellings and had basically occupancy sensors that detected where people spend their time in their homes. And what they found was that overall, people only use 5% of their living space. So, I mean, it kind of rocks your world when you think about it. Like, we all have these ideas of the house, our dream house, or the house that we want. But look at that dining room. I mean, that thing has got one dot in it. That people spend almost no time in the dining room, and the poor old porch didn't even register. At the foyer, of course, has almost no traffic whatsoever. But even that living room, it's a little too far from the kitchen, right? So, not a lot of time being spent in there. And the reason I bring this up is, again, I think sometimes our preconceptions about how we live do not align with how we actually use our spaces. And this has a big impact on energy use. Again, it comes down to priorities. Look at the spaces that we live in, think about that's where we're going to use the most energy, and then tighten down the screws on that energy and water use in those rooms, and that's where we're really going to see a big difference. We're going to come back to this slide, but I just wanted to show you, the difference. This 0.5 gallon per minute aerator on the left costs $2.74, and you put that thing on one of your, faucets in your bathroom, and all of a sudden, you have reduced your water usage from, say, 2 gallons per minute down to 0.5, or at least at the best, you might have a 1.5 gallon per minute faucet. So for a minimal cost, you can reduce your water down. Now, there are costs to this in terms of comfort, and I'll get to those later. Now, the faucet on the right, which I think is about $350, is what's called a touch-free, and that's a 1.5 gallon per minute faucet. My point here is sometimes a simple mechanical solution is what you want. You don't necessarily have to go with a high-end luxury or smart product, although each one does have its pros and cons, and I'll come back to this later on the presentation. Now let's tackle that big chunk of the pie, the heating and cooling, and I just wanted to touch on each of these common heating methods and cooling methods, and just give you a little status update of where the building science is on this. Geothermal, which if you're in the building business or maybe you've heard of it, still a great option. One of the drawbacks to geothermal has been the cost, and a lot of people don't want to invest that. Could be in the $20,000 range cost. There are rebates now being offered on geothermal in some areas. This is, for example, I think this is a carrier product, and some of them are federal. You may have state rebates. The rebates do help a lot, and they help on all of these systems. I believe Carrier also has a system that integrates a geothermal with other more conventional types of heating all in one unit. So that's another option, is these hybrid systems which are coming along, where you don't have to just be geothermal or just be heat pump. You can have different energy sources that power your heating and cooling, which makes it more flexible and essentially allows you to adjust to energy costs as they change. I want to talk about wood burning, and I don't know if anybody's a huge fan of wood burning. I mean, I live in the state of Maine, and we do a lot of wood burning here, but wood is a very finicky source of heating. And I've read a lot and written a lot about research on wood burning. One of the recent research aspects that's come out is behavior has a huge impact on how much pollution is created by wood burning stoves. And I bring up the pollution aspect because if you look at a chart, and I don't have it with this presentation, wood particulates are especially bad in terms of the toxins and stuff that they put out. I know I had a wood burner, a TARM wood burner for a long time, and the other thing that can happen is it went out a second story chimney, but if you opened the downstairs window, you can get a sort of a stack effect where the smoke going out the chimney, especially in the dead of winter, could actually find its way all the way into a circular pattern back in the downstairs window. So wood burning is a pretty, I guess we could say, finicky and complex process. And if you're going to use wood burning to make up for some of that energy footprint and try to do it in a green way, then you need to pay attention also to behavior. Burning other kinds of biomass in a wood burner is especially bad. Anyway, I won't say too much more about that, but I just wanted to bring up the fact that wood, I see wood as an sort of auxiliary heating system, not a primary heating system. I think it's great for spot heating, but you really got to be careful with it when you're using it as a primary. This is an interesting thing that's happened recently. If anybody's sort of as old as I am, you remember those the whole house fans that especially down south, all the homes used to have these whole house fans. One of the problems was, first, they roared like a jet engine, and second, you had very little control over them. You had maybe 3 speeds at best. Well, that has changed, and there's a couple things that have happened. First of all, they have insulated models like this. Second, they're quieter, and they now have smart control. So it might be worth taking a second look at whole house fan systems, especially if you live, for example, in a moderate climate, someplace like North Carolina, where it's not, extremely hot, and you don't have. Well, I mean, there's a couple months. I lived there for a few years, so there are a couple of months where it does get very hot and humid. But I'd say for most of the year, you could probably do most of your cooling with a whole house fan system, especially one that's smart, has humidity sensors, and you can control it from a distance, and it's way different than our parents' and grandparents' version of a whole house fan system. So worth taking a look. This image was one that we created. We did a project called the Celestia Project a couple of years ago, which was an award-winning look at what life might be like in the year 2100. And we had a museum of the future for all the stuff that exists today that would no longer exist in the year 2100. And this was the last air conditioner. In that project, we were pretty hard on window air conditioners, and for a lot of reasons. They don't tend to have great durability records. They make a lot of noise. At the time, they were especially polluting. I mean, they have improved. they're not really an efficient way to cool a space. Because they're so low priced, obviously they're ubiquitous, but they are problematic in terms of their environmental impact. I wouldn't completely rule them out. Again, for spot air conditioning, there are better models available now. For example, this is a 12-SEER Energy Star window air conditioner, which basically didn't exist a few years ago. The other aspect of this is it is smart controllable. So one of the big things about window air conditioners, if you think about it, is you either turn them on or you turn them off, and usually a lot of times you're not even in the building. Like you leave it on and come back 8 hours later and the thing's still roaring. This gives window air conditioners a much more flexible, I guess, use pattern, which can save a tremendous amount of energy. So I'd still think window air conditioners are not the best technology out there, but if you must and you're looking for the low-cost option for a single room or a garage or something, definitely go with one of these newer high-SEER Energy Star units. This, and anybody who's in the business has heard of heat pumps. Heat pumps are all the rage now, and it's kind of amazing to me when I travel around the country how fast the heat pump craze has taken off. I work with a company here in Portland called Revision Energy, and I remember getting a news release from them a couple months ago that said they just installed their 600th unit, which for a small area like this is pretty impressive. This technology has numerous benefits, not too many cons that I can think of. They're also again, smart controllable. You can now, I've seen them now, even the box stores are carrying them. Like I know Lowe's has them where they'll come in and install it for you. There's a couple things I did want to mention about mini splits though. They have they have the ability to dry. A lot of the better ones have a drying mode. So there's a low energy mode that you can use if you're just, for example, say you have a vacation home. You could put this in your vacation home and not have it constantly cooling, but you could use the drying mode and take some of the humidity out of the air and help maintaining a space without excessive power usage. The other thing about mini splits is they are electric based for the most part, and I like electric. I'm not super harsh on gas, but I do think gas has sort of run it, and we are eventually going to be just naturally on a phase out of gas. And I do think that the fracking, we've done a lot of coverage of fracking, and almost no matter how you cut it, it's just a bad way to get gas out of the ground. Going electric also opens up resilience possibilities. And what I mean by that is, if, for example, the electric company in your area, say they had a plant go down and electricity tripled in price in 1 week, you could go out tomorrow, solar array, get a battery system with it, and be able to switch that mini split system to solar or renewable electricity. You can't go out and dig your own gas well, right? So a lot of people ask me, can you heat and cool, using a heat pump system and just solar? Complicated question. You can, and in fact, it's what I have on my building, but you need to do it at this point indirectly. I have Maine has a buyback metering system, so they buy back my solar electricity, and then I can use it sort of secondhand. Now, it is not impossible to create a battery system that would run a couple of mini splits. It's been done, and if you want to talk more about that, we can. I don't want to get too much into the weeds with that, but it does take a pretty significant battery backup, but you can do the calculations, and you could create a battery system capable of running mini splits. But at this point, the batteries are just not quite there. They are coming, however. And I don't know if everybody's heard of this company called Aqueon. They're based in Massachusetts. They had some financial troubles where they sort of went out of business for a while, but I think they're back. And what I love about this is that little block you see on the right. It's a great big block. I guess it's probably 4 feet tall, so it's bigger than the picture makes out. But these are saltwater batteries that do not include toxins. So they're heavy, but the idea is you would put them in your basement and you could replace the salt water. So they're sort of a non-toxic version of a heavy battery storage system. So what I'm saying, I guess, is a good battery has already been built that works. We have the technology. What's really lacking is the economies of scale to create large, household-sized batteries that are affordable. This company there may be other companies out there that are doing the same thing. I know there are a number of battery companies like SMA and of course Tesla that have their own battery systems. Tabuchi Electric, who we've worked with, has a good one too. Everybody is racing to get the affordable battery system, and this is all tied into this heating and cooling thing, because batteries generally are not good tools for heating and cooling, but that will change, and my forecast would be within 3 years it will change. This is a little bit more traditional approach of a central heating option where you get into a really high efficiency gas furnace. If you're going to go with a gas furnace, the efficiencies of these have increased exponentially. So this is the Carrier Infinity 98 gas furnace. I don't think we should discount gas entirely. One thing I like about these sort of the old school whole house furnaces is they do have a very long lifespan. Possibly on this particular one, I believe is where it says hybrid, has the capability to go electric. So under certain conditions, it can switch over, and I think it may even provide cooling. Don't quote me on that, but it's got some other abilities beyond the standard furnace capabilities. But you might want to look it up. It's called the Carrier Infinity 98. So again, a flexible heating option. Trane, this is another type of sort of heat pump, air conditioner. Again, another option for a whole house. Very, very efficient. Far more, up to 22 SEER, which is basically unheard of until recently. So again, spend a little extra, get one of these super high efficiency systems, and it will pay for itself quickly. Controls. Now, we have done at Green Builder a lot of research. We have a data, sort of a wing of our company called Cognition Smart Data. One of the things we've looked at a lot is who buys smart thermostats, why they buy them, etc. We find that with each smart thermostat can save a significant amount of heating and cooling energy. If you don't have a smart thermostat in your home, then you're really missing out on a really low cost opportunity to cut down on some heating and cooling costs. And in fact, there are now rebates in much of the country. Like here's an example, smart thermostat rebate. This is from the Washington D.C. area. This one's for $50 for, and I think it applies to several different brands. There are in some states, there are rebates of up to like $150. And the thermostat itself only costs $150. So essentially, you can get a free smart thermostats in certain states. If you look on the bottom there's a URL down there, and if you want to find out in your state, if it has a rebate or where there's a smart thermostat rebate, just type in that URL down the bottom, and you'll be able to look it up online. One thing I did want to mention, I was talking to a technician, an HVAC technician the other day, and he installs a lot of different kinds of furnaces and on-demand products, on-demand hot water products. And he said what he's running into is skilled technician shortages because the tech is much different than it used to be. There are motherboards basically in all of this new equipment, and a lot of them come from overseas or different vendors. And so what I wanted to point out was, if there's a choice between buying an unknown brand, like going on to Amazon and you see something that looks like a deal, and getting a known, recognized brand, that's maybe 15-20% higher, I would definitely recommend going with the brand, and not just because they're there, but because you could find yourself marooned on the island of misfit HVAC if you don't, because you may have nobody who can fix it, nowhere to get the parts. And some of these things are so complicated that there's simply no one around that understands how to fix it. So again, don't take the risk. Get a brand name where you know you can get service, because you are going to need it. Even if it's a small thing, spend the extra. This is my little plug for NV Energy, who's also our sponsor for this webinar. They also have programs to help commercial owners of commercial buildings. And this is where some of the high-tech stuff has come in. They have systems where they can monitor use of air conditioning in the whole building, and then control it or sort of tweak it and bring the peak demand down when it needs to be brought down. And utilities are really jumping in, and not just NV Energy, but a lot of utilities. They're the places that are sponsoring a lot of these rebates. So, whatever area you live in, I would say go to the utility site, and you may be surprised at some of the stuff you can find there. I mean, it can really cut down your initial capital costs on any kind of energy improvements. And that applies to heating, and applies to water heating, smart thermostats, any number of different energy using devices. If you think about it, what's their motivation? They don't want to have to build new plants. So they want you to optimize, because they want to keep the current infrastructure they have and not have a lot of upcoming overhead as they try to upscale. Next on our pie chart is water heating. Just wanted to touch, we all know about solar hot water. I mean, I like solar hot water a lot. I mean, one of the things you drive around, you often see these solar hot water systems that were abandoned, but you have to keep in mind, a lot of those are 40 years old, and the technology was much different than it is now. Just the ability to monitor the pumping and temperatures and adjust demand automatically using Wi-Fi controls have sort of changed the game on solar hot water. I'm not going to get too into it, but I do think it's worth taking a look at solar hot water systems, especially if you have for example, a pool. Pool systems use a tremendous amount of electricity, especially if they're heated, and there's really no excuse for not having a solar hot water system. On demand, which is probably the one that most people are most familiar with, these units that hang on the wall, right? They're very, very efficient. But again, I repeat my mantra about brands. Be very careful with these, that you get a known brand. These are some of the most, shall we say, complex pieces of equipment. If you've ever opened one up and looked at it, you don't even know where to begin. If you're a traditional, repair guy who used to go in and clean the nozzles on a furnace, like there's so many parts that don't even make sense anymore. You have to be an expert. Notice I have a little note here that says, why not electric? Why do they make these gas? Well, if you travel like in Europe, you'll see there's a lot of electric versions of on-demand tankless water heaters, but they're generally smaller and they're generally spot use. Because what happens in the US, they've had a hard time sort of selling and also making the technology work in the US, because when you pull hot water from an electric tankless, there's a huge surge of electrical demand. Like literally I've seen them used before where every light in the house dims. Sort of like when I used to live near the prison down in Florida. Every time they would electrocute someone, like every light in town would dim. It was kind of horrible. But these electric tankless water heaters, it's that initial demand. They haven't really solved that, is how to make that work with electric. However, there is another option. If you would, for example, say you have a solar system on your house like I do, and you want to use the solar somehow for heating heating hot water. This is a small point of use tank, and these have gotten extremely affordable. I have one a lot like this. I really love it. It basically, it's what I call indirect heating. So what it's doing is it's only heating 6 gallons of hot water instead of, in a typical tank, 50 or 80. The other thing is, if you are long distance from your heating system, which, especially in older houses or modern houses, one option is to put recirculating pipes in, but this, I think, is an even better option because it's a super insulated tank, and it's storing the initial 6 gallons that you use right near where you're going to use it. Now think about a dishwasher, clothes washer, or even just you go to turn the sink on to wash your face or brush your teeth, and having instantaneous. It may be, and what I've found is a lot of times you never even get past the first 6 gallons. So it can be a huge energy saver because the water doesn't have to travel that distance. And like I said, if you've got solar power or you're trying to use electricity, this is a really nice, affordable way to retrofit that. And of course, heat pump hot water heaters also are sort of a fantastic technology that's come along. They essentially take the heat out of the surrounding air, and you can see with my little quote on the side, Bosch estimates a savings of $307 for a family of 4. So an estimated payback of 4.5 years on one of these units. Now, that's without a rebate. But look at this. So like I said, I live in Maine. There's this efficiency. Maine has a heat pump hot water rebate of $750, no questions asked right now. And this is not uncommon. Some of these heat pumps are in the, I've seen them in the $1,800 range, depends on the brand. You might even, on sale, might be able to get one cheaper. You can pay for, I'd say, almost half of the entire cost of the heat pump water heater with a rebate. So that cuts down your payback period to 2 years, maybe just over 2 years. That's pretty darn good. One thing, there is one caveat, though, I would say, with these heat pump hot water heaters, which is they do suck the heat out of the air, essentially. So I have had a couple friends who have put them in their basement, and the basement got really cold. That's sort of can be a downside if you live in a really cold climate. You have to be careful that it's not going to get so cold that you get to the pipe freezing point. There's a positive aspect of that too, though, is they also take the moisture out. So say you're running a dehumidifier in your basement. Those use a lot of electricity, as you know. This unit, if you put this into that same basement, you wouldn't need the dehumidifier because this is going to get rid of some of that humidity as well. So in a way, it's doubling up as a dehumidifier. So that's a perk that I think isn't often mentioned about heat pump hot water heaters. Okay, so take a quick look at this chart of where our other energy goes. Clothes dryers are a big one, right? Clothes washers, that makes sense. The oven, 25 cents an hour or so to run an oven. Dishwasher, 24 cents a load, not counting the hot water. Swimming pool pump, that's an interesting one, 17 cents an hour. That's quite a lot when you think about 24 hours a day. We focus a lot on refrigerators. Like older refrigerators are costing 2 cents. What's that? 48 cents every 24 hours. If you go to an Energy Star version, you're getting that down to what, 1/4? So basically 12 cents a day. I think that would work out too. So let's try to whittle down a couple of these, or some of these big users. Just want to show one low tech option, hanging out your clothes. Lowest tech option of all, right, for replacing a clothes dryer. It's always worth mentioning. I also wanted to mention that 8 states, including my own, have something called the right to dry, so that you cannot ban your neighbor from having a clothesline. There in some states, or among homeowner associations, there's often a lot of pushback against hanging your laundry out. Well, these states said, nope, you can't shut down the laundry line. So kudos to them. Ventless heat pump dryers are very efficient. They've been around for a while, but you may have heard sort of some bad, things about them, and they're not getting clothes dry, etc. Those, I think, were the early versions that may have had some and I think part of that was consumer behavior because people didn't know how to deal with them. Some of them had, for example, a water condensation drawer in them where they would collect the water, and if you didn't empty it, you could run into problems. These newer dryers are very efficient, relatively maintenance free. They also do, some of them do return some heat to the room. If you, I have one, I find living in a cold climate, that's really welcome in the winter time, especially. I use a dry, you know, hangout clothes a lot in the summer. But these are definitely an efficient and well-made devices for in a way to really knock your mechanical drying costs down. Induction cooktops, if you haven't heard of induction cooktops, been around for a while. They essentially, what they do is they heat the pan and or they use, I'm not sure if it's, yeah, they heat the bottom of the pan. There's certain types of pans that work. One of the perks that it also, as it mentions, is you can use cast iron on these. I don't know about you, but I like to cook in cast iron, and with the flat glass tops, you can't really use cast iron because you're going to scratch up the surface, because you're going to have to essentially move the cast iron around. I find with these induction, with an induction cooker, and I have a single burner one, it works great with cast iron. Very efficient because it's not heating anything extra. I like this technology a lot. Dishwashers, okay, you know, dishwashers, again, the dishwasher makers, I mean, kudos to them. They've made these things more and more efficient. You may have heard of something called no heat dishwashers, which it's one of the newest sort of tweaks of how to get more energy efficiency out of a dishwasher. The way that works is the dishes get heated up by the hot water and stuff. So the dishes are very hot. Then when the water is, you know, sort of withdrawn, there's the dishes themselves sort of dry themselves from their own ambient heat. The moisture that's trapped hits the cool surface of the stainless steel and flows out of the dishwasher. So the reason I went into all that technical detail is you want to look for a dishwasher with a stainless steel interior. It's not just about the look, and one that has a no heat system. So it essentially, an energy saving mode can save you, because the heating process can often be a large part of the overall footprint of the dishwasher. Pools, okay, so I know people love their pools. One of the big energy users with pools is just the pump. And what you find with the research is that the older pumps were just very, very inefficient. Simply by replacing the pump to just optimize it to the size that fits the pool can be a huge, well, you see down here the energy savings. Original was 3,000 kilowatts a year. They cut it down to, you know, about a third or a fourth of that energy use. Large savings over the previous year. This is an example of how you could combine solar combine a solar system, and on the top right of the roof is a hot water solar system. So you combine a hot water system with a solar photovoltaic system. So between those two, you could get a tremendous savings on your annual spending for energy use on a pool. And you'll see down bottom, it tells you your 25-year savings depending on what state you live in. In Arizona, this claims you could save $33,000 in energy over 25 years. One of the things, if you look at this photovoltaic panels on the roof on the top left there, I think what they're not suggesting that you have a battery bank. All they're suggesting is that you put up 2 kilowatts worth of solar panels, feed them back to your utility, and essentially you're creating your own sort of renewable energy stream. But they're not saying that you're going to have a battery that would store this electricity. And I'm not going to talk about all of these, but all of these should be present in your home or the home that you are building. If you haven't switched to LED lighting, there's no time like the present. I saw a crate of LED bulbs the other day at one of the box stores for, I think it was $10, and I can't remember, but there were maybe a dozen LED lamps in there. You can drop from, you know, a 40 watts sometimes down to, you know, 2 or 9, or depending what type of LED lighting. So you can make a gigantic reduction in how much waste you are creating with your lighting. Those plasma TVs were awful energy wasters. The new LED TVs have far smaller energy footprints. Another new trend that's happening is micro appliances. It's not just ovens, but small appliances, you know, and this is, again, comes back to use. If you look at your kitchen and look at what you really use in a kitchen, or maybe you're a builder and you talk to your clients, you say, which appliances do you use? Sometimes we can downscale those appliances. Like Bosch makes a whole series of 24-inch appliances, for example, that can, you know, dramatically reduce energy use. Occupancy sensors, you know, if you use them properly, for example, you know, in hallways or in kids' rooms, places where people don't pay a lot of attention, whether the lights are on or off, in the basement, in a laundry room, you can have, you know, not just your lights can shut off, you can now have, you know, occupancy sensors that can tell any number of, you know, appliances or lights or radios or whatever to shut off or turn on in a room. The smart plugs kind of do the same thing. It depends how much you want to fiddle with it. Like, I like the Wemo products. They're pretty simple to use. You can have, for example, on a phone, you can have a Wemo app, and you can have 10 plugs listed on the app, and each one, you know, it might say living room light, and you can tell each one what you want to do. Or you can just program the whole thing from your phone and then walk away. I mean, this is especially good if you're going on vacation, or maybe you do Airbnb rentals, that sort of thing. It gives you a lot of potential energy saving control. Ceiling fans are also smarter now. They're not just on off devices. You can program them to come on when it's appropriate. And finally, compartmentalized refrigerators are just refrigerators like it sounds. They have multiple doors and multiple drawers. So instead of opening the whole refrigerator every time you get a glass of milk, you might just pull open one small section and get just what you need. Again, opening a refrigerator is the biggest energy loser. Water saving, of course, water saving and energy are interlinked, but let's go through the same process. This one's shorter. We'll get to sort of the nitty-gritty of this, but our goal is to reduce consumption and add other sources of H2O. First, I wanted you to look at this chart. Water usage in the U.S. is, as my lawyer says, you know, when I said one time I said to him, this doesn't seem fair, and at the same time I heard myself say it, we both said, but life isn't fair. Well, this chart is an example of but life isn't fair, because, you know, some states are using, on a per capita basis, are using far more water than others. Now, of course, it makes sense in those dark blue and green states over there. Those probably a lot of agriculture going on, right? And some states, we're probably eating a lot of that agriculture from different areas that have high intensity irrigation. I do think that, you know, sort of to brag a little bit, that Maine has done pretty well in getting way up on the far right, getting our water usage down, you know, to a pretty reasonable level. I think there are achievable, you know, there are achievable goals. I think what this chart shows is, you know, it is possible to reduce water usage, you know, with behavior adjustment. What's missing from this chart? Take a quick look at this. There's some major category that is not shown on here that has to do with the residential water use. Did you get it? Irrigation, right? Outdoors. Outdoor irrigation accounts for usually up to maybe even a little bit more than 30% of all household water use. And this is something interesting that I learned recently is, you know, I knew that, you know, different types of sprinklers had different efficiencies, but it even matters the size of the rotors. So, you know, when you have those spinning, you know, irrigation systems, the size of the spray head actually has a significant impact on how efficient it is. Obviously, the best system is the one on the bottom, the subsurface drip, right? So it's a method of drip irrigation. Typically, it's like a pipe that's, you know, underneath some mulch, or sort of not fully exposed, although there are systems that are fully exposed that are just delivering water where it's needed. Now, we have some new tools that help with this. Now, I also want to add the caveat that not everybody has an irrigation system, and it's a fairly sort of class-centric aspect to assume that everybody's got a lawn and a watering system. I know that's not the case. There's a relatively small portion of people that actually have major watering systems. So Racio's company we work with quite a bit, and they have a smart irrigation system, which essentially ties in and tells you, you can go as far or as simple as you want with it, and you can tell it whether you want certain plants to get a certain amount of water. You can program it to work with weather patterns. For example, if rain is coming your way, it can automatically shut off the watering feature. It's, what I like about it is it's a flexible system, and there are other systems out there like this, but very affordable as well. If you have an irrigation system, I would say from the get-go, put some kind of a smart enabled system. This one also is good because we want things that people understand and can use, and I feel like it's pretty homeowner friendly. So even if you're not a super tech savvy person, you can figure out how to run this. Toilets, of course, are a major water user, and here's the thing: toilets have been improving over the last 15 years or so, and they've gotten, and the question is, have they gotten as efficient as toilets can go? And it is important because much of our water use in the home is from flushing. This is a Kohler, I believe, and it's a 1.28 gallon model. So that's pretty good. And when you start to get below that, I mean, I have seen 1 gallon and even 0.8 flush, 0.8 gallons flushes are available too, but those are sort of where they divide up the hard and soft matter, and that'd be a, for urine would be for the 0.8. So let's assume for a minute that we don't really want to go we want water in our toilets, so we aren't willing to go all the way over to composting, which you can make an argument for composting toilets, but let's assume most people in the mainstream are not going to go. How can we tweak water usage even more? Well, first, and now this is sort of a big picture thing. I want to point out that 1 sheet of tissue paper requires 2 gallons of water to make. So this, the use of tissue paper is one of our biggest hidden water users in the country. I actually heard a statistic that said if everybody stopped using tissue paper, we could actually solve most of the country's fresh water problems immediately overnight. And that solution does exist. It's called the bidet, and I always like to plug bidets. And here's the problem: Americans don't seem to be willing to embrace the bidet. It's funny because they're very common in Europe, and I know a lot of people that use them and would never go back. But it's a educational / psychological barrier. But in my view, the only way we're going to get more efficiency out of our toilets is to sort of, I don't think we can individually squeeze a lot of more water efficiency, but we could as a society squeeze more water efficiency out of the sort of toilet usage at large by switching to bidets. That's my high horse of bidet usage that I like to bring up. All right, I'll move on. Laundry, another big water user. There are alternatives. Of course, almost every washing machine has a smart / energy efficient water miser feature now. But there's another aspect, which is speed, which can really help with water efficiency. One thing to look for in a washing machine is, do they have fast cycles? Fast cycles generally tend to be a little more aggressive and get more done with a smaller amount of water. So here, there's 3 brands listed on the bottom here, but they're a little more pricey. But if you're, for example, you're in Arizona, where water is, a real commodity, or a place that water restrictions are in place, you might look at faster washers as one alternative for reducing the amount of water usage. This is some pretty interesting stuff. I actually saw a demo of this at one of the building shows recently. Showers, of course, in certain households, especially if there's a lot of kids, can be a huge water waster. It's a little bit autocratic, but you can actually set timers on showers. I think if it was handled well, you could sort of sell the benefits to your teenager. And the way most of these work is you can set a time limit. They have the ability to override it, but there's usually, all you really need to do is build a 30-second pause before they can restart the shower. That might be the gentle nudge that reduces your teenager shower from 25 minutes to 10. I'm just saying. Anyway, I like it. I think if it's used well, it can be, and even if you just use it for yourself and maybe you lose track of time and you want to set yourself to save some water in the shower, it's a way to sort of give yourself a reminder of your water usage. Low tech versus higher tech. So we talked about at the beginning a little bit about difference between this $2.74 aerator and this $350 faucet. Now, here's the thing is, with low tech, often there is a caveat. So one of the things, for example, that I found with this, I tried out a couple of these little aerators. You turn on your bathroom sink, you put one of these on, you go to brush your teeth, and you're waiting there for 5 minutes for the water to get hot because it's slowed down the flow so much that the hot water never gets there in time. So you have to decide, are you willing to just not have hot water in that sink? Because you're probably never going to see it unless you're really patient. The other aspect is by attaching one of these low flow aerators, you have now tested all of the washers in that faucet. So if you have any older washers or anything that's worn, you could suddenly spring a leak, which is what actually did happen to me. Is the pressure, the back pressure actually caused some leakage. So those were a couple of caveats to the big water savings I was getting. Now with the touch-free faucets, I do like these a lot, especially if you live in a family with a lot of kids and stuff, where maybe you're in that cycle of sickness that happened this winter where people have colds and they're touching things. One thing they've found in commercial settings, so like men's bathrooms, they put these touch-free things in, is they actually did not save water in that setting because people just kept triggering them because they weren't getting enough water, so they trigger them back on, and they actually found that traditional faucets that you had to turn on and turn off were a little more water efficient. I think in the household this probably would be a net water saver, and it's certainly convenient, and it doesn't have the drawbacks of the aerator. So you're going to pay a lot more for it, but you're going to get a little more convenience, and you may even in the end have a similar savings because of the fact that this touch-free faucet comes on and shuts off, whereas the aerator, since you're not getting your hot water, right, you're leaving it on. So these are the complex things that you have to weigh as you decide whether to go low tech or high tech. This is a new product from Uponor called Fin Plus, and this hooks up near the point where the water comes into your house, and it connects, I believe, by Wi-Fi to a system in your house. And what it does, it takes an algorithm of every device in your home, and then it monitors the algorithm of that particular, when I say device, I mean like a water, for example, a hose bib on the outside of your garage and your bathroom sink, and somehow it figures out which device it is monitoring, and also your irrigation. And if all of a sudden your irrigation starts acting funny and you've got an underground leak somewhere, the fin alerts you to the leak. So this can be, leaks can cause a huge amount of water waste, not to mention financial costs. So I really like this product, and there are other other brands of this coming online, but these guys were really the first to get serious about it, and it's a good product. So definitely worth taking a look at, and I think they're moving it quite rapidly to a national distribution. So I wanted to just wrap up and go to our this is our website, and in case you have specific questions, or even if you have an idea, like maybe a product we didn't mention in here that you think we should do an article on, or send us some tips on stuff. We're always looking for good ideas and energy saving ideas. Like I mentioned, you see on the top left, the Align project. That's what we're working on this year in terms of our sort of vision, is how do we align our lives and our expectations, not with how sort of we have traditionally or conventionally been told that the world works and the way we should live, but how we align our lives with how we really live, right? So if you have ideas on that too, that'd be great. We'd love to hear them. Anyway, I will wrap up there and leave some time for questions, and I'll roll it back to you, Mike, and pass on any questions you might have. Thank you.
Great, thank you, Matt. We've got a couple of questions here.
Sure.
So we've got a question from Kevin. Back when you were talking about some of the different solar systems and some of the battery systems, and he wanted to know, can you talk a little bit about Tesla Solar, and not just Tesla Solar, but the products that are available through like some of the big box stores like Home Depot?
Sure. So Tesla, they do the Powerwall and the Powerwall 2. One of the things I do like about the Tesla, so there's a couple different categories. That, for example, let me talk about their batteries first. So it took them quite a while to roll out the batteries. I believe they're supposed to be on the market now. It's always a bit of a mystery whether the stuff's available or not. I know they were late on getting them out. The thing is about the Powerwalls is they are stackable, which is good. Meaning you can buy one and then add another one. I don't recall the exact kilowatt, like the capacity of them. I think when I looked at them before, you would need to have at least a couple of the Powerwall 2s to be able, for example, to run a mini split for any length of time. And even then, you'd only be able to probably run it for a small portion of the day. I mean, really, when you look at even Tesla or any battery system right now, unless you really spend a lot of money, and I think that theirs works out to, I'm trying to think if it was $5,000 or so per battery, maybe more than that at this point. But if you're trying to get to the power level where you can run heating and cooling, you're talking about an exponentially like a bigger system and a bigger, frankly, solar array to charge it. Then it's pretty easy right now to run the other systems in the house. With the possible exception of water heating, you can do most everything with solar. And the other thing, they have what's called a BIPV. They're called Building Integrated Photovoltaic Shingles. I love those products, but they have been around forever. And to be honest, here's what happened: that market sort of, I wouldn't say dried up, it just sort of went away. So I can remember maybe 15, 20 years ago covering BIPVs, and they're the nice looking shingles that look like solar panels. But what happened was the way they were made, they had all kinds of little individual connectors. So the shingles would, you'd have like a little panel with a certain number of shingles, and then they'd plug together, and then another panel, and they'd plug together. But every one of those connectors was a potential break point. And so you can imagine what a problem that could create. And we also didn't have the sophisticated monitoring system. So when it broke back then, you didn't necessarily know where the break was. So one of the cool things we have now is companies like Solar Edge, and you can pull up your app and you can look at the panels. So say one of those panels broke, you would know specifically instantly which panel it was, and you wouldn't have to get up and take the whole roof off. So like a Tesla BIPV roof, you could troubleshoot it remotely, go up, take that particular panel off, fix it, or replace it. So they're a lot more attractive now in terms of their reliability, I guess. So the biggest concern has been taken off the table. Now they are a little more expensive than straight up PV panels, but they do look a lot. They do frankly just look cool. So if you're willing to pay the extra, then it's definitely worth the investment.
All right, we got another question here. We're going to transition to water in a moment. This is going to kind of help us segue to there. So Kevin wants to know if you can compare for us PV domestic hot water versus thermal solar domestic hot water?
Yeah, it's a good question. So if you think about PV, like essentially the only way you could really do PV hot water would be with essentially you got your solar panels and you're driving a hybrid heat pump, like we looked at that one from Bosch. And again, this runs into the battery issue. However, you could create enough electricity. Like I have a 7 kilowatt system on my roof, and I run 3 mini splits off of it. And during the summer, I actually have an excess, so I can, I have enough to power all 3. They're all based on one compressor, but so that's a pretty high powered system. I think the total wattage it uses is close to 4,000. So I can only, and I produce, let's see, what's on my best day? I might produce like 900 kilowatts in a day of electricity, right? So you can kind of do the math on that, but the same thing would be true on a hot water photovoltaic system. You could produce enough electricity to drive like a hybrid heat pump system. I think it would be the major user of your photovoltaic. So I mean, honestly, it's until the battery systems are there to store, because really what you need to do is balance out on days that you have excess, and on days when there's low demand for the hot water, you need to somehow be able to store that. And I mean, if you have a buyback system like I do in the state of Maine, it can work. So as long as you're in an area where they give you solar credits, yes, you could indirectly be heating your hot water with solar. But of course, a solar thermal system is going to be a much more direct system, and it really depends on what state you live in. And one of the problems I live in Maine is it does get very cold here, and it doesn't mean we can't use solar, but we're just not getting as much bang for the buck out of solar thermal.
All right, we want to transition here because we've got a couple questions that came in about gray water.
Yep.
And gray water wasn't really mentioned in the presentation, so we've got do you want to delve into the topic of gray water a little bit?
Sure. Yep. Yeah. I really like gray water. Part of the difficulty with gray water is partly climactic. Like for example, like I said, I live in Maine. I live in a cold climate. The problem is treatment of gray water if you have to do too much treatment to it, it can be counterproductive, because the last thing you want to do is have to use chemicals and that sort of thing to treat you. Now, there is a company in Canada, and if you email me after this, I'll try to find the name of them. It's like something like RCS or something, and they make a really neat gray water system it's a centrifugal system. It's a whole house system. I've actually looked at it for my own house, and it's a 3-part filter that doesn't have a lot of sort of costly reverse osmosis filters or anything like that. It mainly works with centrifugal force and separates out the bad stuff, the solids and stuff from the gray water. Now, I'm talking about a solution that would convert your gray water into actual potable, drinkable water. It's much easier, in my view, the gray water is to use it as for example, landscaping watering. If you can use it for non-potable purposes, then gray water is far less costly and far easier, and there's almost no reason not to. I mean, one thing I will say is the moment you start storing gray water, you change the equation, you make it far more complicated. Gray water simply doesn't sit well. So if you're not filtering it, you've got to keep it moving. You don't want it sitting in a tank anywhere. This is one of the challenges. I think in places in the South or in California, gray water probably makes more sense, and especially in places where there's water drought and you can immediately put it back to use. But even if you bring it back into the house, say you want to bring it back into toilets and that sort of thing, which you still need a certain level of filtration typically to make it. I mean, what you don't want is basically stinky water coming back into your toilets. No matter how much you like the idea of gray water, we still want it to be, at best it needs to be clear and odorless, and that generally implies some level of filtration. So yeah, light gray water, I'd say, use it any way you can, but if you're going to go try to get potable, then you're going to have a fairly sophisticated filtration system that is going to cost money, and it's going to cost money to maintain. And this is probably why more people don't do it.
So, Matt, you were trying to think of the name of the company earlier.
Yeah.
I don't know about the chemical components, but I know of two companies that make a gray water system for the home. One is Grater. I believe they're out of Canada. It's Greyter.
Yeah.
The other company that I'm aware of is Ecovie, which is Ecovie.
Yeah, I think it was maybe it was Ecovie that I was thinking of. Yeah. Yep.
So both of those make a whole home gray water systems, and one of the marketing phrases that's been used with gray water too is laundry to landscape, and that goes to Matt's point about not trying to bring it back in for potable purposes, but being able to basically use the water twice. Yes. That's one methodology as well, because storing does add a layer of complexity. It can be done, but it is certainly a more complex situation.
And I do think, I don't want to mix up, rainwater is certainly much easier. It's much easier to bring rainwater into the house, much lower level of filtration. So, I mean, if you really want a way to, save water or add water, that's not coming from the city to your, your house or your project, rainwater definitely is worth looking at.
And from a logistical standpoint, a lot of times, almost every time really, this is a system that has to be plumbed separately. And so they'll typically use purple pipe to try and designate that, okay, this is reused water versus potable water.
Also, there's another company I just thought of, Nexus, Nexus, Nexus E-Water. I think it's with a hyphen, I'm not sure. But they also, I believe they have some gray water capabilities as well. And the guy's really cool. I've met him. He's it's a small company, but he's a smart, innovative guy, and it's a relatively affordably priced too. But anyway, definitely take a look at them too. Right.
A couple of things, Matt. You had mentioned various incentives that people can seek to increase their ROI. I wanted to make sure that people were aware, and this website's been around for quite a while now, but just as a reminder, the Desire website, DSIREUSA.org. That's a wonderful website. People can look up their incentives that are available in their area, whether they're federal incentives, state incentives. I think it even drills all the way down to maybe even county or city incentives, depending upon how big the city or county is as far as population goes. But that's a wonderful website. You can type in your zip code and get some great information about incentives and rebates. So I want to make sure people were aware of that. And then you were talking too about the toilets. And with the toilets, I know Niagara makes a 0.8 gallon flush toilet that's not dual flush. That's a single flush. But they also have a dual flush, which is a half gallon for liquids. And then
I guess my feeling about that was like I'd have to see it in action, because it's like having seen like at the building shows, there have been a few companies that have these very low water flush, and I think honestly you're only going to get so much performance. It's just not a lot of water. I mean, I think the technology's almost reached its the pinnacle of efficiency, but I'm certainly open to it. I'd like to see it before I'd make the purchase.
Yeah, I know Niagara's technology is such that it works a little differently than a traditional toilet. That's why they're able to get away with the less water. But it is something certainly I would encourage you to check out. Well, we don't have any other questions. I really appreciate everybody's attendance today, and Matt, certainly your time and sharing quite a range of products and ideas with us today. Really appreciate it.
Sure. Thank you all for tuning in, and don't forget to check your email and see who won the Sensi thermostat.
That's right. And also need to say thank you to PowerShift by NV Energy for their generous sponsorship of today's webinar. We'll be back again next week, next Tuesday actually, for part 2 of our series on evolving energy markets, blockchain, and demand-side energy management. So I hope you can join us. That's 2 p.m. Eastern on Tuesday, May 22. So a lot of twos there. Hopefully you can remember all those. Until then, so long. Take care.